Hey there everyone. Today we're going to go over the parameters. I'll be recording this directly from the screen with a camera, as there's really no other way to do it. Messages are chirping away. Can't be helped. Actually, I'm just glad they're still chirping for now, because by the end of 2025, there's a good chance that WhatsApp won't be chirping anymore. Anyway, moving on. Today we'll take a quick look at the GPT-60M7 machine. Let's launch ESCAD and I'll show you some nuances regarding the parameters. For some reason, most masters and specialists keep quiet about this, which is, well, more than a little strange. Let's open up any file. Whenever I show these files or demonstrate them or talk about them, I always explain that certain parameters we set on our machines will only work effectively on that specific machine. On any other machine, they won't be effective. In our case, we have the GPT-60M7 machine, a test on let's zoom in as much as possible on the engraving. So obviously there's material removal happening at the bottom. At high power it's glossy black, like really glossy black. Above that is matte black, but it turned out rough, and then a fast black engraving. Here, if we rub a finger, it's like sandpaper, it just scrapes the skin right off. These are the modified parameters for this engraving. In this case, they also turned out as a rich black here, a good high contrast color. Let's look specifically at this option, which currently has a sort of grayish tint. Let's see what parameters we entered, how it all changes, and how it works. So first off, the settings, speed, power, frequency, or Q-pulse. We set them up, prepare them, but you have to consider a factor like the table we're working from. The frequency range here is bumped up to 95 kHz. Q-pulse is set to 200 automatically. 200 means it'll drop in the source to the required Q-pulse that's actually set by the software. You can set it by the table, but the result won't be very effective because the power will be a bit too high. Let's roll that out and forget about it for now. The parameters we aren't adjusting are those related to Start TC, Laser Off, NTC, Polygon TC, and in advance. Or in the extra parameters, a function like jump speed, the acceleration and deceleration of the mirrors. What's the main catch? I have this interesting little file here. In this file, again, there are parameters. Parameters for practically any equipment. I can't say who created it. Basically a parameter library. Well, let's look at the one for ESCAD 2.0. Let's look at the power. Here, again, everything is sorted by power from 20 to 120 watts. A 60 watt machine. Let's pick the 175th lens. Again, I assume whoever created these parameters just filled these folders in some kind of random fashion. Their file sizes are all more or less the same. So basically, someone just made a table, released it, and people are using it. This is, again, a lib marking for Lightburn files. We won't be able to view it, unfortunately. Let's see, there were some other files here for Lightburn. Strange, actually, for some reason it's the same here. Same thing there. Clib, lib. Okay, now we'll find it under EasyCAD. By the way, it's strange why it's listed under EasyCAD here. I see. These are the files that need to be entered directly into the parameter library of EasyCAD itself. Let's take a quick look and add them here. Okay, let's go in here, the marklib file. Let's give it a name here, say, for example, 1. Password. Restarting our EasyCAD. So it turns out we now have everything we want in the parameter library, but there are many nuances here. There are 14 cuts, so this was all done almost automatically. What's the main catch? It's that the parameters are set here. Again, we were using a 60 watt machine, so we took the file with our lens. So, as expected, we have speed, power, and frequency, which more or less suit us. They match. Q-pulse is 10. The first factor here doesn't help us in any way. The Q-pulse in our machine can be either 6, 9, or 13. Setting an incorrect pulse can lead to improper equipment operation. That's one, and secondly, it could lead to a breakdown, too. The third option, which is the safest, is that the engraving will be incorrect. Okay. Start TC 100, laser off 300. I'll say right away that these parameters are set individually, depending on the speeds and the filling method. So setting these parameters just off the top of your head, in this case, is totally fucking incorrect. It's incorrect because if you change the filling method, Polygon TC will mess up big time. For example, that same bidirectional continuous filling. If you use, let's say, unidirectional with interruption, or bidirectional with interruption filling, then in that case you get a ton of glitches. So these parameters provided by someone on internet resources, and there are many such parameters, and look, they're randomly made for almost any equipment, and someone says like, use them, everything will be fine. I'll tell you right now, nothing will be fine. It'll be as bad as possible. And this factor must be taken into account here, that when you apply these parameters to your equipment, there's a high probability of damage in your machines. Let's look at the Excel sheet. A simple version. Let's look at the Excel sheet. So let's go into the Excel file here. So everything here seems as clear as possible. Makes sense. Hatch angle. Standard. Hatch count. Aluminum dark. Speed 1500. Power 90. Frequency 45. The first question that comes up is, what machine was all this used for? 2021 Alexander Slide Laser Everything. Well, it's clear who did it. Okay, let's say I agree. But there's a slight catch, considering the first factor. First of all, what machine was used here? I don't see it. I don't understand. I mean, what was used here? Aluminum white finish, aluminum brilliance laser ink. That's with a coating, it turns out, of a special spray on the metal surface. So you have to consider all options, but you need to understand the frequency range up to that same 60. It's not an optimal choice. It's practically impossible to work with. So you have to clearly understand that this is not workable. I'm sure he'll see this video of mine now. He'll watch it and say something like, what a jerk, he's trashing me. I'm not trashing him at all. I'm just saying that by applying these parameters to your equipment, there's a high probability of damage in it. Again, aluminum cut. Or cut. Yeah, that's the right way to say it. So look, the speed is 2500. Power is 90. Frequency is 25 kilohertz. For which specific machine? Again. Diameter and distance. This is just insane. Let's look further. That's everything here. So 1,000th diameter distance, meaning you'll have micro movement, and it doesn't even mention the metal thickness here, because there's a high probability that you'll just wreck your machine. My lens is a 110. Well, let's say, again, with the hatching method he uses, I mean, that's the principle of operation. Again, using SCAD 2.0, with 110 lenses, it's clear what machine it is, 30 watts. Look, 30 watts, Mactron GPT. Well, Mactron's the company, the manufacturer. GPT, again, the LP series or the M7 series. I'll say right away that with these specs, 25 kilohertz and 90% power, you're just working the machine to death at the aluminum cut speed, 2500, and with these parameters for distance and diameter. You'll also blow out the Galvo scanner unless it's super expensive and specifically designed for that. So I'll say it again, for all these parameters that someone might use somewhere, keep one very important thing in mind. Let's see what else is related here. The cut, yeah, polyester sheet. It doesn't matter, I haven't worked with this material. So everything I see here, maybe some of it works. But specifically, let's take the point that all these characteristics are superficial. You shouldn't use them under any circumstances because let's open it again. Let's even do it differently. Let's open any file from the library. What do we have there? Well, let's see. Slate, rocks, stone, what else? ABS, skip that. Steel, general. Let's say we click OK, it's applied, let's see, power 500, speed 500, power 71%, frequency 25 kilohertz. For what damn machine is this? And here I see the following situation, since our Q-pulse is automatically set to 10. Most likely his machine or the machines he tested on have nothing to do with Q-Pulse at all, so it's automatically set to 10. But if we're talking about a machine with either 30 watts of power or 60 watts of power, and we're using the 60 watt machine library, then with this frequency range and this power, we're going to run it into the ground. The parameters for these settings are also at their defaults here, which is basically incorrect. Anyone using this library will likely overwork their machine and won't get the desired result. Here's the specs. Have reset. Again, look closely. In this library, a parameter is used. He has at least 1,000th for the circle diameter and a distance of 1,000th. This will be a total strain on the machine and the Galvo scanner, which is basically not good. Regarding cutting specifically in wobble mode, I explain what determines the diameter and distance when we cut depending on, again, different metal thicknesses. I definitely cover this in almost all my videos and in the training materials. I'm not trying to trash anyone here, I'm just explaining, guys, once again. When you take even my parameters, let's open it again. Control L, let's take it. Now the JPT60M7 machine with a 174 by 174 lens, let's open these parameters. You always need to check what you're using and how you're using it, and I always make sure to say that the parameter, for example, for polishing, yes, everything's fine, bidirectional, with interruption, crosshatch, great, no questions there. On this side, we have a speed of 2000, power 25, frequency 280, Q-Pulse 50. We need to check again against the table, because I always say, please check the parameters, I'm asking you. The Q-Pulse here might be set a bit higher for one single reason. Let's see, our frequency is 280 to 52. Yes, the Q-Pulse is higher here because we need to reset it to the random value that's in the source. So the Q-Pulse in this specific case will be set exactly like that. You could set it as needed for the frequency range, meaning it would be around 13 or 20, but you'd be working incorrectly for metal polishing. And these parameters, Start TC, Laser Off TC, Polygon TC, are configured individually, depending on your goal, your Galvo machine, your source, your lens, because again, let's take a ruler for example, the work area. If your work area is 100 by 100, and the beam passing across that area requires the mirrors to move 52 degrees, 26 degrees in one direction, 26 degrees in the other. So your Galvo scanner covers 100 millimeters in 1 second with a 52 degree movement. If you have a 300 by 300 work area, let's look at this logically. The same scanner with the same deflection, a 26 degree angle with a 300 by 300 field. In that same second, it can now cover 300 millimeters, not 100, but 300. So for the same 52 degree movement, it covers 300 millimeters. Consequently, changing the speed, power, and frequency parameters will also have an effect here. So these parameters are adjusted, I'll say it again, individually, depending on the lens, the hatching method, and the material being processed. And on your desired result. If we take, for example, work at low speeds, like 100 millimeters per second, then these parameters are also adjusted individually. The jump speed is also adjusted individually. And the parameters related to mirror acceleration. So it's perfectly logical and clear. I hope it is for everyone. So everyone using these files, be sure to study them carefully. See the settings, adjust them for your machine and your specific goals, and go from there. Here's another interesting example. A cleaning job. Everything here is as simple as possible. Speed 2000, power 12, nominal frequency, nominal Q-Pulse, Start TC, Laser Off doesn't matter because we're using bidirectional continuous where the value matters a lot. Polygon TC. Ignition and fading. These will be short jumps in minor spots that won't affect the engraving quality much. But again, I recommend adjusting all of this here too. This was Igor from the Gravity Engraving channel. Good luck to everyone, all the best, and have a great workday. Make sure your machines are running right. That's all. Bye-bye.